So let's try to use quadratic functions in solving this second problem. At a concert, organizers are roping off a rectangular area for sound equipment. There is 160 meters of fencing available to create the perimeter. What dimensions will give the maximum area? What is the maximum area? So before we begin, we have to start with representing our variables. So we have let x be our width and y be our length. So based on the given, we have here 160 meters of fencing material available. So if that's the fencing material, that would mean that is our perimeter. So isn't it for perimeter, we have 2 times the length plus 2 times the width. Or in this case, since we use x and y for our width and length, we can do 160 equals 2x plus 2y. So now from that equation, let's try to solve for y so that we'll only be dealing with one variable. So we can do minus 2x on both sides. So that's going to be 160 minus 2x equals 2y. And then we can divide both sides by 2. And we will get y equals 80 minus x. So from there, since we're also looking from the area, and let's recall, area is equal to length times width. Or in this case, area is equal to x times y. And since we know that our y is equal to 80 minus x, we can substitute that x times 80 minus x. So that would be our equation now. Area is equal to x times quantity 80 minus x. If we will expand, it's going to be 80x minus x squared, or let's just try to put the x squared first. So that's negative x squared plus 80x. From here, let's complete the square to change it into vertex form. So it's going to be negative x squared minus 80x. And then to find the constant term, we have to do negative 80 divided by 2 quantity squared. So that's going to give you 1,600. So plus 1,600. And then of course, since you added here, you're going to subtract, but times negative from here outside, from our a, that means it's going to be plus 1,600. And then we can simply write this as negative of x minus 40 quantity squared plus 1,600, giving us the vertex 40, 1,600. So from the vertex, we can say that our maximum area is 1,600. And one of the dimensions of the rectangular area for sound equipment is 40. In this case, it's the value of our x. So going back to our original formula, area equals x times y, we can substitute our area with 1,600 equals 40y. And to solve for y, divide both sides by 40, and you will get y equals 40 as well. So that means our maximum area is 1,600, and the dimensions of the rectangular area for sound equipment is 40 meters by 40 meters. So now it's your turn. Try this next problem. A handball court is to be surrounded by plastic stripping 30 meters long. One side of the court does not need the stripping because it is a brick wall. What must be the dimensions of the court in order to obtain a maximum area? what is the maximum area. If you got the dimensions 3.5 meters by 7 meters, then you are correct. And the maximum area is 24.5 square meters. If you have questions about this problem, don't hesitate to approach your teacher to ask for help.